Welcome back to Pop Goes the Stack, where shiny demos meet production traffic and reality files a ticket. I'm Lori MacVittie, and I'm standing by with incident notes. This week, we're going to answer the question, what happens when AI finally writes secure code? No, really, think about it for a minute. Try to stop laughing. Just try. Because if AI actually starts consistently producing secure by default code, the security industry changes, right? AppSec has to shift from catching basic mistakes to dealing with all the new ways autonomous systems can accidentally set production on fire, as Joel will no doubt explain in just a few minutes. The problem is that AI models still produce vulnerable code at hilariously consistent rates while sounding extremely confident about it. So this week we wanted to ask the question of Ken Arora, one of our security experts here. Hi, Ken.
Hi, all.
What happens if AI gets good at secure coding? What breaks? What evolves? And does secure code even matter when the real risk starts moving higher up the stack into orchestration, autonomy, and machine-made decisions, right? Because that's a very different conversation. So let's have that. Go ahead, Joel. I know you've been waiting. You're chomping at the bit.
Look, I think there's two ends to this. One end is when AI generates more secure code, and I think that the systems that assist coders are getting much better at generating quality code. Then there's the flip side of it, which is AI helping fix vulnerabilities in code that perhaps humans have created, perhaps other AI coding assistants have created. Everybody's read the statements about Mythos and the elements that create multi-stage attack chains and find deeply hidden security flaws. So I think that in the end analysis, I do believe that the bar is raising for all of us in terms of the code quality that's necessary to sustain within enterprise applications, and certainly the code quality that's necessary to sustain a cybersecurity product line. And so, obviously we've been taking this very seriously, for sure. But it doesn't skip, it doesn't really address the fact that, one of the deepest misconceptions in cybersecurity is that insecure systems exist because of bad programmers. They don't necessarily. They can. But for the most part, many catastrophic failures come from flawed incentives or rushed deployments or excessive complexity or poor operational decisions, weak governance, bad supply chain trust, business pressure. Perfect syntax doesn't produce perfect systems all the time. And so I think the onus is shifting from security being a find and fix flaw problem to a figure out who has authority problem. I think it just shifts the bar. I don't think it necessarily moves it downward.
Ken, rebuttal. You're good at rebuttals.
No, I generally agree with Joel. I think Joel mentioned this, and I think it's worth repeating just to emphasize it a bit. There's what happens in the short term and what happens in the long term. In the short term, we have a lot of human written code that was honestly poorly written. Maybe it was, some of it is whether it was, unchecked pointers, invalid inputs, whatever, all these things. And AI, Mythos, Glasswing, all these things going on are very good at that. And I think we're going to go through a period, and I don't know whether it's going to be 6 months, a year, 2 years, where all that is going to get cleaned up. It's going to be pretty chaotic and pretty wild for a little while we do that. And then and then at that point, most of the code being written will either be cleaned up or be AI written. And so it'll be mechanically correct. And I think we'll have to have very good code. And then we do the shift that Joel talks about. I agree with Joel. It's going to happen. It's I think when we're talking about this a little bit earlier off the record, we were talking about cars, the analogy. And I can have somebody who is a perfectly safe driver. It's like, I want to be safe. I'm going to, do everything right. I'm going to wear my seatbelts. I'm not going to go over the speed limit. I'm going to make sure I keep following distance, all this stuff. And I faithfully follow my GPS off the cliff. Was that safe driving?
Yeah.
Well, he safely went off the cliff.
Yeah, safely. Perfect code and perfect approaches can still implement terrible ideas flawlessly. That's the bottom line. And so So I think that once we get to the level where code quality comes up, and perhaps the quality of components that applications are comprised of, that it comes up, the focus will naturally shift to the things that are not necessarily related to code. Things like logic issues in applications, things like authority or control violations. I'm going to make a controversial statement here. I think it's controversial that in the future, enterprise security teams will look more like governance teams than they will operations or engineering teams. I think they tend to look a little too much like engineering teams today. They get very involved in the day-to-day find and fix issues. But I think that's going to be set aside in favor of looking for things that are actual authority problems in applications. That's probably what's going to happen with it.
I hear some people crying right now, like, because you compared security to governance. I don't disagree with either of you that eventually, right, this moves up the stack. This is a time-tested technology cycle evolution where, right, we address things at lower layers and then we have to move up the stack. It is up the stack from code and bugs to logic, risk, authority, things like that. My contention is that we are very, 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 very far from that, given that this is a vicious cycle. The AI has been trained on bad code. It produces bad code, but it can also recognize it. But now it's supposed to fix it. How? How does it know what good code looks like when it's been trained on, 20 years of, not good code?
Yeah. Well, I don't think it's a universal that all AI systems generate bad code. I think that over time, as they're being trained with human assistance to recognize code quality issues, that they're getting better and better. I mean, we've seen a remarkable advancement, especially in the reasoning systems related to doing multi-stage design and building ever more complex systems. That kind of introduces another question, though. If AI begins generating wonderful code and it generates it much faster, it's going to generate a large amount of it, large amounts of code, interoperate with each other. Does AI reduce software risk faster than it reduces complexity? No. Complexity is an authority or an operational problem, right? So I think again, in the great analogy of the toothpaste tube, with security issues, we're squeezing one end of the tube and the other end fills up, right? So once you eliminate bad code and you eliminate quality issues, then it becomes a matter of looking for authority or operational issues or logic flaws. So again, I don't think the security industry is going to disappear. I don't think the need for security products will disappear, but they'll have to change focus for looking for authority problems and looking for behaviors that represent possible attacker traffic.
Yeah, I think that last word, behavior is what matters. I mean, it's not the dry sort of governance we sometimes think about with compliance. It's really thinking like an attacker. And it is not, attackers don't necessarily, there's a class of attackers who are bad guys who will look at code and look for code vulnerabilities. But there's, I think, increasingly a class that says, is the business logic of this application correct? A really well-known example of that is, right, the people who buy tickets, the airline tickets, Taylor Swift tickets, and resell them. I mean, that's a really simple example. The code's working perfectly. They just didn't think about the business angle. I think they're going to talk about being an adversary, and that's going to be the shift. I'm going to ask you guys. There's a premise here that seemed to be implicit in what we're saying, which is that this is all a friendly, cooperating ecosystem that's all trying to make us better. What happens when bad guys are using AI to subtly inject vulnerabilities, not trying to make the code better, they're trying to subtly inject things? That gets harder and harder to detect.
Yeah, no, you're absolutely correct about that. It doesn't skip past my notice that every era of computing that we've been through so far believes that it is close to eliminating software insecurity. Every single one has had elements in time where hey, static code analysis or dynamic code analysis, it's going to reduce software insecurity to levels that are not even measurable. Well, honestly, what it does is it just creates it eliminates one class of problems, but it unlocks a new class of problems. things that we didn't imagine before. And so I think that that's largely what's going to happen here.
Right.
I don't know if it eliminates.
Adversarial use of AI, that is certainly a new class of problem.
No, it is. It's new. I don't think that we've eliminated old classes of not necessarily vulnerabilities, but attacks. Like if you consider, I mean, a firewall is a firewall. We've had them for 25, 30, a long time. We've had them a long time. They still get deployed and they still stop attacks because attackers don't stop trying to volumetrically overwhelm your system, and firewalls are really good at that. It didn't eliminate it. We learned how to deal with it and how to mitigate it, but then a new class of attacks came up, and those were like layer 7 at applications, like, oh no, API attacks and HTML and manipulation, and we're figuring out how to solve those. And now we're getting another one like, oh yeah, logic, orchestration, how these things interact, because that changes, right, how the execution happens. And to Ken's point, if we don't think about how someone might abuse logic, we're not going to be able to stop it. And maybe AI can help there. Like, tell me, how would you abuse this? Maybe we turn it around, right, and start thinking like the attackers. Just a thought.
No, that's fair. I mean, going back to Joel's point about complexity, what happened? We started at the network. People wrote software with IP addresses, and we said, no, you don't need to do that. We had firewalls. People went up. We went up the stack. That enabled a whole class of applications. Came with REST and HTTP, and now we're getting to the point where AI is writing code, and spec-to-code is how I think of it. Right? You write a spec. The time to get code from that spec gets increasingly close to zero. Okay, what's going to happen in that world? People are going to write lots and lots of specs. People are going to be writing specs for things who have never written a line of C code in their life. And are they going to think about that spec in a way that they're thinking about what's going to happen if I wrote the spec incorrectly? Software engineers are hopefully being trained to say, think about how something gets abused. Think about what either a not competent user or a malicious user might do. That's part of the training. People are going to be writing specs. They're not going to be trained that way. Ergo, to your point, Lori, there's going to be a new attack surface, and people are going to go for that.
And that makes sense. That we don't normally think like that. Maybe because we don't want to think like, oh, people are going to abuse this, because then we have to recognize that there are people who enjoy abusing systems and doing all of these bad things. And, that's sometimes people don't want to face that. And they don't think like that. It also requires theory of mind, which a lot of people don't actively develop because that's not a skill that we teach them early on. So maybe not only are we talking about security having to change, but also how we teach like comp sci and engineering, and start introducing that earlier so you get in the practice, right? You have to build that muscle to be able to say, okay, this is good. How will they abuse it so I can protect against it?
Yeah, I think Ken is right. When people begin to write specs in English language and not computer language, computer languages have things that allow you to focus on types and logic and passing logic from one side to another, whereas a spec that's written in human language doesn't necessarily have to have that. And so the AI tries to fill in those logic blanks. And if people don't write with clarity, if they write something that's ambiguous, again, these systems may produce perfect code, but they will embody bad ideas flawlessly, and that's going to be an ongoing challenge. I think I've said on one of these podcasts before, this is kind of the golden age of the liberal arts degree. People with journalism degrees are actually fairly well equipped to navigate how to write specifications for applications, because that's what it trains you to do. It trains you to write unambiguously. But not everybody's going to have that training out of the box. And so, again, there's still going to be flaws in logic. But I foresee a time when the weakest link is no longer code. The weakest link is authority and logic. and that security tools and security teams are going to need to shift to address that.
Yeah. Yeah. Okay. Right. I mean, you're saying boundaries and behavior, which is that's my current, right? Mantra.
And behavior.
Boundaries and behavior. B&B. That has to be our new approach to how we secure things. What are the boundaries in which they can operate, and what behavior indicates they might be trying to get outside of those boundaries? And we need to move toward more of that, because prompt is the new layer, right? Free text. That's, you're right. I mean, people write prompts. I've seen some prompts. Wow. Okay. That's why this is dangerous. Yeah.
Yeah. So let's go forward a few years. Let's imagine a future 5 years from now where, developing code, developing agents is democratized. Anybody can do it. They embody exactly what you tell them to do. In what are the safeguards?
No, it's all right. It's all right.
I can't. I don't want to imagine this future. It's scaring me.
Prepare yourself. Let's take a deep breath.
Okay.
What do we, and the analogy, and I'm just sort of thinking this through, the analogy is a little bit like dealing with other, I'll say human agents, right? You have human agents. How do you, governance goes back to governance still, right?
Mm-hmm.
How do you put guardrails around them? And I guess just one observation I have is the guardrails sometimes have to be a lot more formal than the general directions, right?
Yeah.
Laws are a lot more prescriptive. Guardrails around LLMs might be more deterministic things like rule-based systems.
Yeah. I think that's correct. Security isn't becoming obsolete. It's just getting promoted and changing form. It's evolving from, the static rule, please escape your SQL queries, to please ensure your autonomous AI agents don't accidentally destabilize civilization. That's all.
That's a simple rule. You've got that one written, don't you, Jill? You want to share that with us? How do you codify that?
Right. Until the AI says, oops, I destroyed civilization. My bad.
Yeah. Who does it tell? Who does it?
Sorry about that.
Oh my goodness. Oh my goodness. So I'm sure we could continue this conversation and continue scaring me. But so I don't have a heart attack, and we can wrap this up in a reasonable amount of time. It's not here yet, but it is moving that direction. People are using a lot of AI today to write code, to fix code, to help augment these processes. So, what can we take away from, it's not there yet, but it is moving there, and we do want to leverage AI to help us get more secure.
Yeah. My takeaway from this is the future of security is no longer about fixing, shielding, or protecting broken code. It's about governing systems or operating systems well that are finally powerful enough to work exactly as intended. That's my takeaway. We're shifting the game in security, and it's got to be more about operational control and, like you said, boundaries.
Yeah. It's my take would be pretty similar. It will do AI is getting closer and closer to the point where it will do exactly what you tell it to do. And so now the onus shifts, security becomes, be very careful about what you ask it to do.
That's pretty simple.
It is pretty simple. And I agree, right? We're not there yet. It is getting better every day, but we do have to start looking up the stack, right? That value and security, everything has to move up the stack. How do we deal with the new challenges introduced by new ways of integrating, orchestrating, and operating, which is, of course, going to add complexity because we just added a new layer, and that's what happens. And complexity is the enemy of security, right? I've heard that somewhere. So remember, AI isn't going to do your job right now, but start using it to help you figure out what those attackers might be doing. That's a wrap for Pop Goes the Stack. So hit subscribe before the next wave of tech buzzwords hits your planning meeting.